Okay, I skipped several questions and I've chosen question 13. This is a long question. It is pretty tough. Okay, let's start with the question reading. The picture below shows electronic baby swing consisting of metal and plastic frames and a seat suspended from the frame by two arms. You have two arms here. The baby is placed in the seat of the swing and electric motor moves the swing to and fro. The line diagram is a side view of the showing dimension. So this one is the line diagram, the side view. Okay, the first question, that the seat and its arm have a mass of 3 kilo. If a baby of mass 3.6 kilo is placed in the seat, what is the tension in each arm of the swing when the swing is at rest? So if at rest, that we will always associate this with the translational equilibrium, whereby the force here would be equal up and down, and up here will be given by tension and down will be given by the W. So number one is that T equals to W. So this tension is referring to both of the arm here, and the W is always equal to mg, so T equals to mg. The mass over here is the arm and the seat, it's 3 kilo, and the baby is 3.6, so you have to multiply by gravity. You have this value, about 64.6 Newton, but you need to find each arm, tension for each arm. So what you need to do, so tension T in each arm would be half of it, 64.2, and 64.6 over 2 is about 32.3 Newton. So that's the first answer. Straightforward. Okay, and then the question proceed. Now you have a moving swing moving through a distance of 0.9 meter in 1.6 seconds. What is the centripetal acceleration at the lowest point shown in the diagram? So centripetal acceleration, always the equation is v squared over r. V squared over r. I mistaken this square word, let me erase. Okay, so you need to ask yourself what is the v, what is the r. So refer back to the diagram. The r is 0.6, and how about the v? The v here is pretty tricky because the v here is saying that this swing is moving 0.9 meter in 1.6 seconds. So the v here that you need to use is just take the normal d over t. Yeah, so distance travel 0.9 in time of 1.6 seconds. So you have approximately 0.5625 meter per second. And I need to warn you that you cannot use this 2 pi r over t. You cannot. It's tricky because you don't have the time here, the period. Okay, so you couldn't use this. You can only use this based on the best estimation given by the question. So you have to know that you cannot simply use a formula. You have to analyze the situation. So this is v squared over the radius of curvature is 0.6. You have to treat significant 0.527 ms minus 2. So this is a centripetal acceleration at the lowest point. Okay, so that's for part B. And for part C, how about the tension in each arm of the swing when it's motion and at the lowest point? When it's moving and at the lowest point, if this is the free body diagram, you have W acting down, you have tension acting up. So you have to find tension in each arm. So we know that T minus W must be equals to the FC, because the net force is pointing upwards. So your T must be greater than your W. So I have to find the tension. So tension is Fc plus W. Fc is always M, A, C in this case, plus the mg. So I can extract the M and I just add up these two numbers. Mass, just now what we have for the mass is the 3 kilo from the seat and the 3.6 kilo of the baby. Easy, we just got it to be 0.2527. and gravity is 9.8. So do the maths, you have 68.2 Newton. Use your calculator. And in each arm, how about it? In each arm, your tension would be half of the calculated value. Okay, so divide by 2, so will be, the final answer will be 34.1 Newton. Okay, so that's for part C. And yeah, that's all for part C.